Hello there, Khalid Al-Malawani here. We have seen a lot of sensors and the operation of various modules so far, and we will see quite a lot more today. But an important question to ask is how do you determine which sensor to use? That is a very good question, and there's quite a few answers to that. And the first answer is depending on what you have. So in this case here, the sensors I'm using are all from the most complete starter kit, so the Mega 256 Zero project by Illegal. I'm also using the illegal car kit, so I'm using the very sensor that they have implemented on there. So those will be either my two go-to. But another thing to note, and that is actually quite significant in especially if you want to get quite good at this, is that you have to be quite appreciative in reading the data sheet. So as you can see here, these are all different data sheets for various sensors I currently own and various other sensors out there. And and it is always good practice to always have a list handy where you can find the data sheets array and make sure that the names are quite searchable. It will be perfect if they follow the same name on usually when you buy any kit or if you're keeping track on Excel, as I am also doing, you will have all the different components right on your kit here. Um, but it is also quite so it is nice that if I show you here, if you have a list of all the various data sheets here in a document nearby, then just make sure that you keep them handy and the names are quite searchable. Now, having said that, if we look at the data sheets, um, usually especially if you don't know if you're going to use the sensor yet, give it a quick overview. Uh, see maybe the voltage of operation. Voltage of operation is quite important. In this case here, the button does not have a voltage of operation. It's just how much it can resist basically. But in so you usually look for the voltage of operation, especially for anything that has that produces power of some sort or is a sensor, because if it does not work with your power level, it's useless. Especially if you have, let's say, like the Arduino MKR series. The Arduino MKR series do not have a 5-volt output. That means if you have any sensor that requires a 5-volt component, it will not work. So this here, for example, this sensor operates on a 5 volts and needs less than 20 milliamperes. So this may not necessarily work on an MKR series for the water sensor. If we look at other ones, some other ones have two based on the circuit breaker. Either works on a 5 volt or 3.3. The 3.3 is gaining a bit more popularity, so a lot of the sensors will operate on 3.3 nowadays. But still, 5 volts is quite important. So that will be the main thing I'm looking for when I'm determining which sensor to use. The second thing to read is just look around and see if you can find any of the accuracy or anything mentioned here. So in this case here, this one is a humidity sensor, or this one is a large microphone sensor. It operates at certain temperatures and humidity, so make sure that these apply to your work condition. Usually, if you're working at home, most of these will work, but sometimes if you're designing things for maybe stuff to go to Peru, as I'm currently designing, then it is important that you account for the temperature there and maybe the weather if it's an outside source or an outside device. So you have to make sure that you account for that here. And also a lot of dash sheets will provide examples on how to use them, which are quite nice. Does not necessarily have to. As you can see, there's not really a formula for a data sheet. They can be as simple as one page, or they can be quite extensive, such as the this one here. So, yeah, of course, the more information it has, the more better it will be for you. And then another thing that's quite useful is use Google. Google is extremely important for you. What I mean by Google is actually searching. In many cases, because especially working with Arduino, somebody will most likely have used your sensor before. So if you just give it a quick search online, you will find reference codes, you will find libraries to use, you will find quite a lot of things. The only thing is also about Arduino, because so many people use it, you might have to, don't be afraid to try more than one thing, right? So these are all important things to keep into consideration when you're interfacing a sensor. Now, going back to the kit that I just showed you, if we look at the different sensors, available here, we can build something that will look like this here. So this here is various sensors implemented into one here. We can just go through them here. So we have the humidity and temperature sensor at the beginning here, and then we have a photoresistor with a series with a resistor here. That's how it should work. And then we have a sound sensor or a microphone commonly known as. We have a real-time clock. We also have a motion sensor at the back here. So you can find a picture of this in the description if you want to uh, build it on your own exactly as how I built it just to test the various features here. The code that I'll be showing in a few minutes here also will be available. But what I'm trying to get at is a lot of, especially the connections, because a lot of times, yes, for example, in the humidity and temperature sensor, here, it has an S for where you should put the signal, but it doesn't tell you where ground and VCC should connect to. So just make sure that you just read the things properly because maybe some of them are based on such as the LED, for example. You have to properly wire it a certain way, or it won't really work. So because it is a diode, so same thing with a diode as well. But this is what we have in this case here. Now, an important practice that you might have seen in all my codes so far is I always keep out a pinout. This pinout will allow you to easily connect stuff because you usually have more sensors and projects than you have on microcontrollers. So you usually use one microcontroller throughout your project. So make sure that you keep your pinout so if you return with it, you can easily build it back. And some of the requirement components are also here. I also include the libraries that needs to be installed. And remember, you can install any library by just going to Tools, Manage Libraries. And in this case here, you require 3 different libraries for the various sensors we'll be using here. So I will just show you them really quickly here. If it loads, here we go. So Edu Intro, for example, is the first library. So this one is developed by Arduino LLC, version 0.012, the one we're currently using. It has a lot of different sensors you could use. So whether it's a thermistor, a piezo, which I think there is a piezo in the kit here. Of course, LED and blind are quite straightforward. The DHT11, which is what we're going to use, the PIR motion sensor, is also has a library for, and yeah, and those and the servo as well. So all of these are quite important, and we have here. Next one we have is the IR remote. Now something I will mention about the IR remote library. It's slightly complicated to use because it uses a lot of the timers here. It does not work with the servo with the servo library. So that means anything that has a servo library will not work. As such, if you in this case here, we're using the edu intro. The edu intro does use the servo library, so it will not work as well. If you just use the servo library, it will not work. So there is a workaround for it, but it gets a bit too complicated. So just keep in mind that if you do want to use the servo library and they are remote, you have to use them separately in 2 different projects. Otherwise, you can look into the workaround. It's quite popular online, just a bit hard to implement. So this is the IO remote that we have here. And the last one we're going to use here is the RTC library for the real-time clock module. And the RTC library is developed um, by Adafruit if it shows up. Okay. So the RTC library is developed by Adafruit here, and it is a quite popular library as well. So this is what we have here. Of course, we need some wires to connect everything. So following the pinout that I have here, I can quickly build my device here and get it to go. So once you have everything built using the pinout that you have outlined here, you will look something like this. Now you will find a picture of this here in the description video, as well as a schematic to be able to connect it. And so you can see how to connect the various sensors in here. Now, a lot of these sensors here have power LEDs. In this case here, the RTC module and the sound sensor both have power LEDs. So you usually know that you connected at least your power correctly if the LEDs on both the RTC and the sound sensor module is connected. In this case here, the other ones do not have a power LED, and as such, you just need to make sure that you did everything appropriately. Now, how this code really works here is that the various modules are either declared that have their library at the beginning, or an object instance, or just a definition for a pin, as for the sound sensor, the photoresistor, and the PIR. As well, the IR receiver, as you can see, is commented out because it won't interfere with the edu the DHT11, so the edu intro library. And finally, the RTC module also uses the wire library, such just like the MPU and object instance for it as well. And then the serial is divided into the same way. So the photoresistor, sound sensor, and PIR also all require just a pin mode. And the as you might notice here, the one of these sensors here do not need to be initialized, and that will be the DHT11. It does not need any serial input for it. And then finally, we have the clock module. If you can see here, the RTC begin is set here. Now, you can see here something called the RTC adjust time. This should only ever be run once ever. So that means that when we launch this code here, we can comment this out. And I should probably comment this. And I should say that the following code should only be ever run once. What this code does, the RDC module here has a battery. So the battery means that it will keep this clock module forever. The only time you will need to launch this code again is if you change the battery. That means it died, right? So you reset. So in this case here, so we have so we will beginning and adjust it. I can actually launch the code now, and then it will compile here. Now, while we wait to compile, we can look into the code further. So this code here says that it will only take about 500 counter instances of the loop here, and then it will stop, and then it will stop counting because has a while one. And then we can see the various implementation of the RTC, of all the modules. So as you can see here, the RTC has a function known as RTC now. It's just like an update function, which is also the same for DHT11. It just updates the time of the current moment and just prints it in terms of in decimals, and just prints the various inputs here. And the same thing occurs with the DHT11 here, but it prints out the the humidity as well as the temperature in Celsius and Fahrenheit, which are all functions available in the DHT11 library. And then the photoresistor is an analog sensor. So as you can see here, we're using analog read in this case. So it is connected to A15 for the photoresistor pin, and it's a simple light level sensor. As well as a sound sensor has two inputs, either a digital input. The digital input, if there's any sound, basically, if it passes any thresholds, is there any sound, it will light up. If there is no sound, it's completely quiet, which is slightly hard to do actually. It will slow down. Now, something worth mentioning also is a note. The sound sensor has a potentiometer, which can be used to set sensitivity. That means that if you turn the potentiometer here, if you see the sound sensor right here, the potentiometer is the blue box right here. If you turn it towards, if I look at the robot from the back here, if you turn it towards the right side, it will it will decrease the sensitivity, and if you turn it towards the right side, it will increase the sensitivity. Going further here, we have the PR motion sensor. So if there is any motion detected, it will light up. Now, a lot of the motion sensor is all set up in terms. Usually, a lot of codes are set up digitally. That means you write code to set up. The motion sensor is slightly different. It's all set up using various physical components on here. So on the back of the digital of the motion sensor here, so the motion sensor is the module right here. You can see two orange potentiometers. So the potentiometer that is near the center here is actually So the potentiometer on the inside is actually the sensitivity adjustment, as you can see right here. So if you turn clockwise, it will increase range from either 3 meters to 7 meters. And the potentiometer on the outside, that is the time delay. So the time delay, what it does is that if it detects a motion, it will keep it high for the certain amount of time that you said here. But that will only be true if you put your jumper, which is the yellow thing right on the side here. If you can see it, it's the yellow one right here. And these were the potentiometers, so it's right on the side here. These are um, this one says here that if it's set to H, so if it's put on the top side, every motion detector, the delay will restart. So basically detects every motion. If it's set to low, it will just do what the timer delay would do. So it would turn it to low, wait 3 seconds, and then you can add another or you can create another input. If there's anything detected, or it will print out motion detected. Finally, the R receiver cannot run while the edu intro is running. And further to that, you do need an IR remote to be able to test it, which I do have. Um, but I will not be testing it for the purpose of this code here. So we did upload our code. If we just launch it, we launch the serial monitor, we can see here, and it does produce random data, which is quite normal. If you do work with a lot of code, sometimes you go have different serial inputs depending on what you're doing. In this case here, I do not believe that we need a 38400, so we can just keep to the default 9600 here and just re-upload the code. So it's currently uploading here. And we can just open the serial monitor once more. And as you can see here, everything is running smoothly. So we have a humidity of 43%, a Celsius of 24. The RTC module here is slightly incorrect here. So the idea here is that I believe I commented the statement out before actually making sure that it works, or the battery died. No, actually, that seems like the battery died because it did set up to the value. So, anyways, the RTC module here is currently working. Now, to make sure that this does not happen, you need to make sure that you set it up correctly. Now, there's two different types of adjustment. Usually, you can use adjustment based on date and time. The date and time is based on your sketch. So your sketch always saves the date and time, and that's what it saves it to. Another way you can adjust it actually is using RTC adjust and put in a certain date. Um, so in this case here, if I just keep it that way, in this case here, I'm going 2020, December 23rd. Let's say it is currently, or let's say 19, um, 33, and then we will launch this code here. And then it seems like I just forgot a semicolon, which is okay. And then we can just launch the code again. So it is uploading, it is done. We can just open the serial monitor once more. And then, so it seems like the RTC after you hear that, and that's how you would notice it is left. How you would notice actually is that because it doesn't change. If it doesn't change, that means the battery on the RTC did stop. Now, another way to actually have a real-time clock is actually use millisecond. Though account for it's not really a clock. It just accounts for the time that the robot has been going. Another way you could actually do this is actually show the timestamp by pressing this button here, and they'll also include the current time based on your Arduino sketch here. So this is what we have now. Because I'm standing right in front of it, of the motion sensor, and it is quite hard actually to go away, to keep it empty for 3 meters. It will always say motion detected. And for it to not say it is too loud, it has to be completely quiet, which is not really possible. But you can see from the sound levels and from the light here that's about the same. And then as you can see here, about 500 times it did stop. So this is a valid code. You could actually use this as a reference to your own code, because remember how I said in the beginning, you can look for either references for to develop your code, and you could use that to implement your various sensors And so this is readily available for you, and it will be available in the description. So that concludes so that concludes the statement of how to use sensors, how to make sure they work, and just the various implementations they can use from them. As you can see here, some sensors are more accurate than others, so it definitely requires testing or reading more about the data sheet or just reading the Arduino forum. There's a lot of different sources, especially because Arduino is such a popular service and language. However, just keep in mind that it is not really necessary to go buy new sensors or accurate sensors. As every sensor, you can build a digital filter of some sort just to make it as accurate as possible. But yes, it will not be as accurate as more expensive sensors. Most of these sensors here are about each one are about maybe $3, $5 Canadian. So they're not too much, and it is. But the most important thing I will emphasize one more time is make sure you get accustomed to reading the data sheet. They're quite useful, and they do provide a lot of information that you could find useful throughout your coding experience. With that said, that concludes how to interface various sensors. In this case here, just to reiterate, we did see quite a lot of different sensors, whether ones that work with libraries, whether it's ones that work with analog, and even ones that work with digital. There's quite a lot of sensors out there. Aside from that, I hope you found this video useful, and looking forward to seeing you on the next video.